Hello friends, let's solve this question on the board. We have this indices, very easy to do, and don't forget to subscribe and follow if this is your first time on my channel, and share this video with your friends so that others can also learn maths. And if you're not yet in my WhatsApp community, click the WhatsApp button to join my community. We are doing maths in the community. Alright, so in this case, there are different ways we can solve this. Let's take the first method. So let's simplify the basis. So 6 can be written as 3 times 2. Then raised to power 1 all over 2n. Now no need of putting 1 all over 2n again because 1 times n is n. We have n all over 2 multiplied by. Now 12 can be written as 4 times 3. Then 4 times 3, 4 can be written as raised to power 2 multiplied by 3. Then raised to power n plus 1 multiplied by 27 can be written as raised to power 3, then raised to power minus 1 times n will give us n. We have minus n all over 2. Then we can divide it by 32 can be written as raised to power 5, then raised to power 1 times n will give us n. So we have n all over 2. This is the first step. Now let's simplify further. So in this case we have 3 times 2. Let's open this bracket. So we can write this as 3 raised to power n all over 2 multiplied by 2 raised to power n all over 2. So everything is inside the bracket will be raised to the power. That's a lot of indices. So the next one multiplied by, now in this case you're going to open this bracket outside. So the power here we open the bracket, we have 2 raised to power 2 times n will give us 2n plus 2 times 1 is 2 multiplied by 3 raised to power n plus 1, then multiplied by 3 raised to power. Now 3 will open the bracket, 3 times n will give us 3n, so we'll have minus 3n all over 2, then all over, then 3 raised to power 5, 5 times n is 5n, of 3 raised to power 5n all over 2. This is the second step. Now if you look at them, we have base 3, base 3, base 3, and we have base 2. So now let's use the law of multiplication again. So work with base 3. So we add all the powers together. That's the law of indices. So when you see an expression multiplying each other with the same base, you add the powers together. So in this case we have 3 raised to power n all over 2 plus, the next one here is 3 raised to power n plus 1. The next one is minus 3 raised to power 3n all over 2. Then multiply it by, so in this case let's go with the base 2. So in the base 2 we have 2 raised to power n all over 2 plus 2n plus 2 minus, this is division, so the division changes to minus. We have minus 5n all over 2. That's all. Let's simplify this fraction. We can say all over 1, all over 1, all over 1, all over 1. So the denominator here is 2, 2. Okay? Then LCM of 2 and 2 is 2. So we have all over 2, all over 2. Now let's simplify further. We're going to have 3 raised to power 2 divided by 2 is 1. So 1 times n will give us n plus 2 divided by 1 is 2. 2 times n will give us 2n plus, now 2 times 1 will give us 2 minus 2 divided by 2 is 1. 1 times 3n will give us 3n. Then multiply by, we do the same thing here. 2 raised to power 2 divided by 2 is 1. 1 times n will give us n plus 2 times 2n will give us 4n plus 2 times 2 will give us 4 minus 2 divided by 2 again 1. 1 times 5n will give us 5n. That is all. So this will give us equals to n plus 2n will give us 3n, and then minus 3n will give us 0. So we can still divide by 2 again, divide by 2 again. That still remains the denominator. So since we have n plus 2n is 3n minus 3n 0, we are left with 2. 2 divided by 2 is 1. So we'll have 3 raised to power 1. Then from this side multiply by 2. So in this case n plus 4n will give us 5n. 5n minus 5n will give us 0, so we are left with 4. 4 divided by 2 is 2, so we have 2 raised to power 2. So in this case, 2 raised to power 2 is 4, and 3 raised to power 1 is 3. 3 times 4 will give us equals to 12. So the correct answer is 12. This is the best way to do it. Don't forget to share with your friends. In the next video, I will solve this in just 30 seconds. Make sure you're following. I'll see you in my next video.